So in this, we are going to see about the data exploration by using a data set, which is nothing but the iris data set. So that is what we are going to see. We have certain, functions I have written over here to explore the data from the, by using the various, data exploration functions which are available. So this is what we are going to see in this particular, session. Okay. So first one is nothing but, so iris is a data set which is a flower data set, okay, which has got sepal length, sepal width, petal length, and petal width. So these are the things, and there are three different classes like virginica, like versicolor. So these are the different type of classes which they have, classifications which we have in that particular data set. So in order to just know about the dimension, so it's a small data set with 150 observations in that. Okay, so that is what, say, we will see about what is there in it. And so the names, so these are the basically the attributes like sepal dot length, sepal dot width, petal dot length, petal dot width, and species. So there is something called species is nothing but the variety, so we will see that as well. And so this will just give you str of this will give you the structure basically. So it's like for each of there are 5 different species. So setosa, versicolor, virginica, and I think 3 different ones. So each of the attribute has got 150 observations. So that is what it shows here, and it just gives you the structure. And say this attributes, or there is a function called attributes, which will give you some details about what are the names. So what is a data frame? So data frame is like we have already seen that. So the various all the values will be taken together and put it as one different data frame, right? And now this just selects the first 5 values in the iris data set. So these are the first 5 values. So all the 5 species are basically setosa. So this is how we will use. So 1:5, and there is no ending here. So that is what it is. So this is how you will select the first 5 data. And if you give head, okay, that also gives you the almost the 5 to 6 first data will be given to you. So one more data is extra. So head means first 6 data will be given to you. In the same way, if you want to just select the last data from the data set, you could also give this one. So this selects the last 6 data from the data set. Hope you are able to follow. Okay. And now the next one is basically we are what is that, we are drawing a sample of just 5 rows. So if you want to say randomly get 5 data, then what you have to do is that you have to give, say, a variable. So you are taking sample means we have already seen this, we are just randomly taking some values and 5 different values, and we are just putting it into some variable. And say if we give idx, it just gives you some random values. Okay, 5 different values will be given to you, right? And say there is another way. So in another way, it just gives you 5 different values from randomly from the data set. So this is also possible. So these are just different ways for you to explore and more about the data. Okay, so this is like just the values of the sepal length alone. Okay, you are just getting the values of the sepal length alone and just the first 10 values. Okay, so that's it. And then if you are giving like this, it just gives you see, this is also possible. So that means that it will take the first, whatever be the first attribute. I think the first attribute is sepal length as well. So it's all the same. So either you can specify the attribute here, or you could just give 1. So that means that it will take the first attribute. Say if you have given 2 here, it will take the values from the, say, second attribute and display. That's also you could just see here. So 3.5, so up to 3.1 it is print. So it just gives that particular values and it just prints to you. So that is how it works. So these are different types of ways wherein you could explore the data. So if you want to simply know the details of the data, okay, you can just use this. So summary of iris, so it just gives you what is the minimum, maximum. So it's kind of your the complete details about the data. So what is the third quartile, so the minimum value, the maximum value, the first quartile. So it's kind of the first point summary. Okay, the 5-point summary of the data will be given to you, and each species, so you have in each species you have got 50 observations. So all those complete details about the distribution of your data can be understood by this particular summary of iris. Okay, and now the next one is we have already learned about quantile, right? Okay, so quantile is basically based on the quartiles. Okay, and it is based on percentile, if you say. So you could, if you're giving, say, for the sepal length, if you want to understand the quartile, so in this particular data sepal length alone you want to understand how the data is. So 0% is 4.3, so 25 percentile, 50th percentile, 75th percentile, 100th percentile. So all this information will be provided to you by this, right? And say, no, I just want to specifically know that in the 65th percentile, okay, what is the value? Okay, so that is also possible. So here, we are giving like, 0 0.1, 0 0.3, 0.65. That means that 10th percentile, what will be the value? 30th percentile, what will be the value? And 60th percentile, what will be the value? So if you want to know that, that is also possible. So it is customizable. You can customize it and give in the function, right? And now the next one is basically the variance. So if you give the variance, it just gives the variance of one attribute, say sepal length. Okay, it gives the, so the variance of that particular attribute is basically 68%. And there are different plots and visualizations that could be applied to help you to understand more about the data. So once you do the visualization, okay, so this is basically the histogram. Okay, so you are asking for the histogram, and one second. So this is regarding the visualization. Say if you are actually trying to visualize the sepal length in form of the histogram, then you could see it is getting displayed here. So all the plots basically will get displayed here. Okay, in this particular area. This is the view area. Okay, and then say if you want to get it in a table format, okay, then all the different species will be displayed to you in the form of table. And then say if you want to get the pie as a pie chart, okay, so then what happens is, then here it will be displayed as a pie chart. Okay, so all the visualizations basically come over here. Okay, so that is what you have to, then you can save it as an PDF or save as an image. All those options are also available. Okay, and then the most useful chart, that is the bar chart. Okay, so bar chart, so the three different species, this is all about the species, so the bar chart will be given to you. Okay, and then we have to also know about the multivariables, like how the relationship between two different variables. So say if you're taking the relationship between sepal length and petal length, say we are trying to understand the covariance. Okay, so you could get that there is a correlation of covariance of 1.2, so this is positive, so there is some kind of a relation, okay, between these two variables. That is what you can understand from that. Now say, no, I want to know about the relationship between all the different variables, the covariance between all the, that is also possible. So this is kind of a matrix which will be printed in RapidMiner. You have already seen, but what happened is that there it was more beautiful, that's all. Here they're all functions, so it's kind of programming, more of programming. So this is the correlation. So correlation between two different sepal length, so it gives you 0.8. So there is a high correlation between them, sepal length, two attributes, sepal length and petal length. So that is what you can understand here. Now say if you want to understand the correlation between all the different attributes, that is also possible. So you could see here all the different variables, all this, so sepal length to sepal length. So you could see here sepal width, and width is 1, so all these diagonal values will be 1. And see there is a negative correlation, so petal length and and this is sepal width. So they don't have much of a correlation between them. So it's kind of a negative correlation. So one increases, the other one decreases. So that is what you could understand. Say if it is petal width and sepal length, they are positively correlated with a correlation value of 0.8. That means one increases, the other one increases. So there is a positive correlation. And always understand, for correlation, again I'm telling you, it's between -1 and +1, and it shows the strength of the relation as well. Now the other one which you could just try is that the aggregate. So it's like you are getting the sepal length and species, okay, and then you are actually you're taking the summary and you're just printing everything. So it's kind of an aggregate of everything, so minimum, quartile, so everything is printed. So kind of your 5-point summary is printed here, and this is just aggregate of everything. And this is for sepal length, for the attribute sepal length. Okay, so like that, the function is possible. And then you have you can also go with one second, the box plot. So this is really important for you to understand. Is there any what is that outlier? Okay, so there in Virginica there is an outlier here, basically you could see that, and almost the data is distributed almost fine, because mean lies within that particular range, it lies almost similar. And what will be the minimum value, maximum value, everything could be understood for each and every species. You'll be able to understand it separately for the sepal length. Okay, sepal length versus species. So sepal length versus species, this is the distribution of the data you could see. So so that's all. So for the sepal length for all the 3 different species, okay, what is the kind of the distribution of the data? So like that you will be able to understand by using this particular box plot. So box plot help you to really understand about the outliers, right? Okay, and then the next one is basically you are coming out with more complicated plots. Okay, so say, one second, so you are basically, okay, one second, yeah, so here you could see that it is kind of a scatter plot. So each and everything, how basically each and every one are distributed. Okay, so for the sepal length versus sepal width, okay, how it is basically distributed could be easily understood by this particular thing. So and the next one is you can add noise, so that is the jitter function. So there is some function called jitter function. Say if your data set is so good, it does not have any missing values or anything, then it will not be, you will not be able to understand the difference, right? So in such cases you will have to sometimes induce the noise over to your data. So in this cases you are basically inducing some noise over, so you have actually induced some noise or jitter to your data. So that is also possible by one particular function called jitter, right? Now I want to see the data in a more smoother way, smoother scatter. So then you could go and use this. So it just gives you a smoother representation of how your data is basically distributed. So it's a scatter plot basically, but a smooth scatter plot. So this is just for you to understand that there are different type of visualization techniques available. There are n number of functions available. That's all. And this is something which we commonly use in data mining. So this is your scatter plot, but kind of a pairwise scatter plot. So it's like, say if this is kind of for sepal length, petal length, everything is there. So all the different attributes will be here. So all the combinations are shown here. So when you take the sepal width and when you take the sepal length, okay, how will it look like? So how the data is basically scatter plot is distributed, how the scatter plot for these 2 pair of values will be. So like that you can pairwise clearly identify. So there is no major relation between these two. So here and all you could see there is a positive correlation here. So all these things could be understood by if you are able to read and interpret the things, you'll be easily able to, by simply viewing the pairwise plot, you'll be able to understand how 2 variables are basically correlated. So this is kind of a correlation plot and the scatter plot, but a pairwise scatter plot. And sometimes if you want to use a bigger visualization technique, so sometimes this will not be, this libraries, it will throw you an error, so this will not be available. So in such cases, say if you are using it for the first time, sometimes this library will not be available. So you have to go to tools and you have to install the package, and here you can give this ggplot. So you could use this ggplot and install. So it just asks me like, you have already installed it, do you want to? So I'm not doing it right now. Otherwise what happens is everything will be installed here. It might take some time, so it will just everything will get installed, that's all. So if any of the packages is missing or something like that, you have to go to the tools and use it. And always save this, because the thing is, sometimes this you are basically going to a server which is outside your system, and then you're trying to access the packages from there and downloading it locally into your machine. So basically what happens is that sometimes when you try, it will not work that way, that easily. So sometimes you will have to close this application, then again open it and then try it. So such kind of hiccups could be there when you're trying to download or install the packages. So all those hiccups are part of this. And this is again another way of seeing. It's a quantile plot. Basically it's a q plot. So quantile plot, and it's a quantile plot for sepal length and sepal width. And all the species are basically all the three species are basically shown. So this is also a pairwise plot, but this is a quantile plot. That means that it basically shows you in the or each percentile what happens. So everything will be shown here. Okay. So this is also an example. Say if you want to save this as PDF, so that is also possible. So you could just save this, okay. And say here when you go to the files, so in your R data mining trials, you could see this is available, right? So your plot will be saved here, right? So if ever you're saving something, that will be actually available here. Say this is my plot, okay, this plot. So if you want to save all the plots, that is also possible. So this is something which I have tried before. So all the plots has been saved. So say if you're working something on a paper or something like that, say if you want to save all the plots which you're doing, so that is also possible. So for that yeah, so for that you could just use a pdf.save, the plot of save.pdf file. So for that basically you have this my plots. I'm just changing it to say the new plot or something like that. I'm just changing the values here, and if I click here, you could see that new plot has been developed. So in this new plot you could see okay, so something have gone wrong here, because maybe it's already open or something like that, right? Otherwise basically what happens is that this new plot, you will be able to usually see it. Okay, so probably it is just saving. Okay, something went wrong. Okay, whatever it is. So this is the same way basically I have actually saved this uh, my plot as well. So you could see that. So this is how basically once you do it, you'll be able to save this file, and you'll be able to see that for your further purposes. Okay, thank you. So hope you understood what I have told. So this is what it is. So this is all about the data exploration part. So now actually you have actually tried doing the correlation, covariance, the basic kind of things upon the data here. And we have not gone in detail about how to deal with the missing values and everything, but still you if you want to understand more about the data here, it is possible by doing this. Okay, so that's all you have seen, and the kind of the visualization technique. So that is what we have seen. So thank you so much. We'll see later. So in this video we will see how to remove the missing values. So for that we are basically taking small data, so air quality data. Okay, so this is the air quality data. So you have got 153 observations. Okay, and these are the various attributes you have. So there are 6 variables and 153 observations. And now we are just going to understand about the whole data. So in this we could see there are a lot of true values and there are a lot of false values. So true value says that the values are correct, and the false values which you could see here says that that they are not, they are the missing values. Okay, now so just to understand, okay, so you could see now what we have done is that we have just taken only the correct value. So here basically we had 153 observations, and now when we are taking the complete dot cases, so we are taking only the complete dot cases. So we are taking only the complete dot cases from the air quality, then there are only 111 observations. Okay, and so, and now once we are omitting, you could see it is in a new one. So na dot omit, what it basically does is that it just omits all the not available values. So that is what you could see. So this is what, by these two sentences are almost same, but you could see here there are 153 observations. Okay, and from that you are basically you're omitting all the not needed values, the na values, and you are just taking you're omitting it, so you will have 111. So here now your new data set has got only what is that 111 observations. Here it just, in this particular line, it just shows you that okay, how many observations are if you are omitting the false values, okay, what would be the number of observations. So 111 observations, here you are saving it to y, so that when you give y, basically you will have so now just to make you understand, what I have done is I have just taken the structure of the y. So in the structure of the y, you could see that you have 6 variables and there are 111 observations, and it has also been told that okay, there is some action has been done, that is omit action has been done. So where you have actually omitted so and so number of values. So that is what you could understand here in this particular example. Okay, so now wait, yeah. So I just want to show you this way also. So you could also use a R script for doing it. Okay. So either you can run it here in the console, or you could also do this. So I have the same lines here. Okay. And control enter. So when you control enter, you could see the same thing has been displayed here. So this is also possible. So this way of saving things of working down with the program is also possible. So you have an R trial.r which is saved here. So just wanted to tell you this. This is also possible. Okay. Uh, that's all for this particular thing. So this is another example which we are going to see for the missing values. So I'm just making up a data set. Okay. So name is like say John, Tim, and I have got a lot of missing values here. And then about the sex, we have different missing values here, and age we have missing values here, right? So basically 10 values, and then you're putting everything in a data frame, and then you're going to remove. So is na of dt means it is a data frame. So from the data frame you are going to check for the na values. So this is what we are doing here. Okay, once again, this is what you are doing here basically. So you could just select everything and control enter. So you could see everything is run here. So each and every values, you could also see the values which are printed over here, and this is the data frame with all the values, and the values are specifically printed, and you could see all the, it's just displaying all the na values here. So just to add more onto it, I'm just, checking for the sum. So this is an aggregation function which we are working on that, and say if you give control enter, it says that okay, there is for NA of dt, say if you're taking the sum, okay, what will happen? And then you can also apply say mean over to it. Okay, so when you apply mean, one second, you could just select this particular line alone, so that it will only could be control enter. Control enter is the, so mean is this one, and you could also, this I'll tell you what this line is all about. It is in the age. Yeah, it is in the age. I have actually given some values called 99. So what I'm telling is say if you are actually doing a transformation, or you are actually getting the values from integration, say if you're getting the values from multiple data sources or somewhere, sometimes in some particular databases, say 99, it is nothing but it has to be considered as not applicable. So in such cases, it could be the that has to be understood by that way. So if you see 99, that has to be replaced, and that has to be considered as na. So you are just telling the system that if you see in the age attribute, if you see something called 99, then you have to consider that as na. So that is what is the meaning here. So you could see, and if you simply type dt, okay. Okay, So it will just show you that 99 has been here. When you see here, the 99 has been replaced with NA. So this is what you have to understand here. So all these things are basically possible, right? So this is all kind of, how to deal with the missing values. So now once if you want to omit it, you could just use na dot omit of dt. So I'm just using a control enter. So you could see that, it has actually omitted all the na values, and finally what you have got is that, say, the name, men, so everything, whatever is actually, so John men 45, Tim men 53. So these are the only two complete details which we have. All the other columns has been dropped. Okay, so this is the answer which we will get. Okay, this is the answer which we get. Say this is our data set. So from the data set, it is very clear. The first two rows. Okay, so John men 45, its complete data is there, and Tim men 53 is completely there. All the other data is not complete. So that is what you could see. So it has omitted all the different datas. So yes, so this is one way of dealing with the missing values in, so you have seen basically two different ways of dealing with it in R. So this is one example for you. So hope you could try more and explore more, and you could do more of data exploration. Okay, thank you so much.